Hi, it's Michael Schnitzer. I'm in the unfinished space of one of Stanley Martin's home. We're going to just talk about some things from a mechanical perspective and maybe even from a building perspective. Probably the first thing to talk about is what is a 9-foot foundation wall. So here you can see the blanket insulation, so it's a little hard to see the wall, but if you look just below the blanket insulation, you can start seeing the concrete foundation wall, and it goes all the way up. It's 1.5 inches below the floor joist here. So a 9-foot wall, as measured from the concrete slab to the underside of the floor joist, is actually 8 feet 9.5 inches. And the reason it's 8 feet 9, the wall is absolutely 9 feet, but this concrete slab is sitting on the footer of the wall, and it's 4 inches thick. So 9 feet minus 4 inches is 8 feet 8 inches. On top of the wall, you can't see it, is a pressure-treated sill plate that runs around the entire perimeter. That sill plate is 1.5 inches thick. So if you take the 8 feet 8 inches to the top of the wall, add the 1.5 inches, you magically get the number 8 feet 9.5 inches from the unfinished slab to the bottom of the floor joist. Some other things to point out are, if you look at all these pipes in the unfinished area, these are drain lines. So here you're seeing 2 hot water heaters. The water heaters have a catch basin, and off the catch basin is a pipe. So if God forbid the water heater failed, and by the way, it's recommended once a year to open up the valve and drain any of the sediment at the bottom of the water heater. That'll increase the lifespan. So that's why you have that valve there. But anyway, if God forbid the water heater failed with regard to leak, the water would build up in the pan. It would go into this 1.5 inch pipe and then drain right down into what's called the foundation drain. So that's these 2 drains. The other drains are really condensate drains. So in the summertime, condensation is just a natural byproduct of the air conditioning system. In fact, you'll see here off of this system, I don't know if we can zoom in, but you'll actually see the condensation coming from the bottom of the pipe right into the foundation drain. So we've got a condensate drain here going into the foundation drain, and then we have some from other systems, condensate drains draining into the foundation drain. So if you ever see water leaking, not leaking, but coming out of a condensate drain, if it's in the summer, its purpose is completely, it is what is supposed to happen. Just one thing with regard to condensate drains, and that is you should always clean the condensate drains from buildup. I would say once a year, because if there's too much buildup in the pipe, if God forbid I'll show you over here, a furnace and the condensate level ever backed up, again, you have the same theory, you have this catch pan, but if this ever backed up, it would go into the condensate drain, but if the condensate drain is backed up, then it's going to overflow out of the pan. So you always want to clean these condensate drains once a year, just as a preventive maintenance item. Some other things to point out with regard to furnaces is if you see here, this gray material, see it here, here, look all through this, the ductwork, that's called mastic. The purpose of this is with any joints, they coat the mastic on the joints, and it locks and seals at the joints to prevent air leakage. So every joint gets sealed, and then on top of that, what we do before drywall is we do something called a duct leakage test. So just to make sure that the sealant was applied properly and that there's no leakage, we pressure test our HVAC ductwork to ensure there's no leakage. Obviously, if there's leakage, we're going to fix it before drywall. So we perform a duct leakage test to verify that the mastic was applied properly and that the ductwork doesn't leak. Obviously, a more efficient distribution system is it's a benefit to the overall efficiency of the heating and air conditioning system. A couple other things to explain to you. Over here is a sump crock. That's the lid. Within that sump crock is a sump pump. The pump has a float, and when the float rises based on the water level of the crock, it will turn on the pump, and the pump will then pump water into this 2-inch PVC line, and it gets pumped outside the house. So the pump is inside this crock, and it's pumped outside the house. Some customers will opt for 2 sump pumps. Some customers will opt to add a marine battery backup in addition to just the single sump pump. So if you're in an area which has potentially a high water table or a perched water table, you may want to add that redundancy. If you're in an area that has significant times of the year where there's power outages, you should definitely consider a marine battery backup. The only other thing you could do in lieu of a marine battery backup would be to install a gas-fired generator. Still do the 2 sump crocks and the 2 sump pumps, but instead of a marine battery backup, the gas-fired generator would come on if you ever lose power. The last thing to discuss is, if you see in this sump lid, you'll notice there's a cap, a white cap, and then if you look up next to this furnace, there's a white PVC line. See, it's not connected to anything coming down through the floor. So what we do is we never assume that there is radon underneath the slab. What we do say is we're going to passively add a radon line, so that once you move in and if there is radon detected, you just connect that PVC line that comes down through the floor system into the sump crock lid, right? Obviously take off the cap and connect, and then you would put a small inline fan to pull the inert gas up through this pipe that would connect and out through the roof. So those are just some things that we'll talk about today in the unfinished lower level.